CCNA routing and switching, connecting networks, skills assessment. You must connect the network devices and configure those devices to support various WAN protocols. The first WAN protocol you will configure is point-to-point protocol with chat authentication. You will configure access lists to limit network access. You will also configure GRE tunnel to allow BGP updates between the east and west domains. Configure device basic settings. Configure PCs. Okay, on PCI, click on PCI, desktop IP configuration. Configure all this. Okay, for IPv6, this okay, the default gateway is this on instructions, but the should be this. Okay, this is an error. Okay, this is an error. This should be the default gateway because the default gateway should be the interface on the router. On the router, on router one, the interface gigabit 01 should be the default gateway. Okay, so should be this. Also should be this, but the link local address on the PCA should not be equal to the link local address on gigabit 01 interface on router R1 on router 1. Okay, so link local address on router should not be equal to the link local address on PC. So that's why I prefer to use this as the default gateway on PCA. Okay, and for PCB, now configure R1 or router 1. Okay, I will use a notepad for this. Disable DNS lookup, no IP domain lookup. The hostname at the end, hostname should be R1. Encrypted privilege exit password class. Console access password Cisco. Line console 0. Password Cisco. And don't forget login. Exit and remote access configuration. This is for SSH. the domain name west.com, case sensitive, IP domain dash name west.com, enter user and password. Okay. Username is user and password is Cisco. The crypto key, okay, crypto key generate RSA modulus 2048 bits, 2048 bits, modulus 2048. Okay, and on BTY lines, SSH only, line BTY 0 to 15, all lines, and transport input SSH. Also configure login local to use the local username and password for authentication. Okay, and next. Okay, when you will configure the crypto key, you need to configure the host name before. Okay, before to configure the crypto key, you need to configure the host name. Encrypt the plain text passwords. Service password dash encryption. Message of the day banner. Use this. Unauthorized access is prohibited, and use this symbol as the delimiter. Banner message of the day. The delimiter and unauthorized access is prohibited. Unauthorized access is prohibited. Okay, and try to insert this on the router 1. Go to router 1. Enable configure terminal. Set the hostname fields before the crypto key. Hostname is R1. Okay, and paste this configuration. Copy, paste. Okay, and now you can see on Packet Tracer the configuration of crypto key is different. Okay, so you need to add general keys. Crypto key generate RSA general keys modulus 2048. Paste, enter. Very nice. It's generated, so it's very good. The domain name, the user, SSH with BTY line, encryption. Very nice. And configure interface gigabit 01. Interface gigabit 01. This gigabit 01. Set the layer 3 IP address, the description, the layer 3 IP address, the IPv6 link local, and activate the interface. Okay, and configure this. router 1, interface gigabit 01, the description. For example, this is the West LAN. Okay, you can use any description, but I will use West LAN. The IP addresses, the IP address, okay, IPv6 address, okay, be careful, IPv6 link local address, link dash local, and activate the interface, now shut down, exit. Okay, review. Okay, configure R2. Router 2 is internet. Disable DNS lookup, router name, the encrypted privilege access password class, console access password banner. Okay, this is the okay. It's the same configuration as router 1, but remove the SSH access. This okay, DNS enable secret, console banner. Okay, so this is the configuration for this part. Enable configure terminal. Don't forget the hostname first, hostname R2. Copy, paste. Very good. Now configure R3. Command line interface. Okay, is very similar configuration as R1. So copy this down here. Paste. And the difference is the domain name is east.com. So here east.com. Okay, disable DNS lookup, very good. And enable secret, line console, very good. The domain name, user, crypto key, and BTY. Domain name, user, crypto key, BTY. Banner, the banner. And anyway, I will add the service password encryption. Okay, and copy this to, okay, router enable, and configure terminal, hostname R3. Copy this, paste. Okay, no issues, very nice. Configure gigabit 01. This is gigabit 0. Interface gigabit 01. Set the description is LAN. For example, you use any description. IP address 192.168.41. IPv6 address. Enter IPv6 address. The link local FBA0:1 link local. No, shut down to activate the interface and review. Okay, very good. Now configure point-to-point protocol connections. Okay, the connections between R1 and R2 and the connection between R3 and R2. Okay, but for better understanding, you can configure, you can document the IPv6 addresses. Okay, here. Configure point-to-point protocol connections. Configure R1 serial 000 this interface serial 000 this interface, and configure all this interface serial 000 description, the description connection. Point-to-point connection to internet, for example. Okay, the IP addresses. IP address 09 165 200 225 255 255 255 252. IPv6 address 001 DBA ACAD A colon 1 prefix 64. Okay, link local address. Okay, this is very good. Link local. Set the encapsulation point-to-point protocol. Not shut down to activate the interface. Okay, and review. Document. Okay, very good. And chat authentication. exit. Uh, okay, on serial 000 point-to-point protocol, authentication chat. Exit. The username and password for chat authentication. Username R2 should be the host name of internet router. Okay, R2 and password Cisco. Enter. Now configure loopback 1. Configure loopback 1 is a simulated web server with user access. Okay, this interface loopback 1. Configure this. Okay, interface loopback 1. Okay, and IPv4, IPv6. IPv6 address. Link local. Very good. This is okay. Very nice. Exit. Okay, you don't need to. You don't need to apply. You don't need to apply the shutdown command because interface loopback, change it state to up. Document here. Now configure R2, the internet router R2. Enter. Remember the console password is Cisco. Enable password is class. Configure terminal. Configure CL000, the connection to router 1. Okay, configure all this. Description. Point-to-point protocol connection to R1. Enter IP address 226. Enter IPv6 address 2001 DBA ACAD A:2 prefix 64. The link local should be different on different router. Link local encapsulation point-to-point protocol. Shutdown. Authentication. Okay, point-to-point authentication chat. Exit. The username for and password for point-to-point protocol authentication. R1, the host name of the neighbor, and Cisco, the same password. Username R1, password Cisco. Enter. Then wait a minute. Okay, and configure 0001, another interface, the connection to R3. Interface serial. Okay, and now you can see line protocol of serial 000 changed state to up. Okay, now configure the another side, the connection to R3 interface serial 001, the description point-to-point connection to R3, the addresses, to 165, 200, 230, 252, the IPv6 address, B colon 2, prefix 64, link local, the same link local is the another interface, no shutdown, to activate the interface. Okay, this link is point-to-point protocol, but this link will use HDLC. Okay, and document very good. Now configure R3 serial 001, this interface, the connection to internet serial 001. Enter password. Console password is Cisco. Enable password is class. Configure terminal. Interface serial 001. Description. Connect. HDLC connection to internet. Okay, so you can modify the description of serial 001 on internet. This description. Okay, you can use any description, but only to be strict. HDLC. Okay. Okay, and continue with R3 serial 001, the description, and now all these IP addresses. IP address 192.165, 200, 229, 255, 255, 255, 252. IPv6 address 2001, DBA, ACAD, B colon 1, prefix 64. Okay, link local, different link local on different router. No shutdown. Exit. Very good. Okay, state up on serial 001 and protocol up. Very good. Enter. Now configure IP routing. Configure IP routing on R1. IPv4 default route. The default route to R2 via the exit interface. Okay, go to R1. Enable Cisco. Enter Cisco. Enable class. Configure terminal. IP route. The default gateway. And use the exit interface. You know it's serial 000. Okay, this interface. Don't worry about this message. Enable IPv6 unicast routing. IPv6 unicast dash routing. EIGRP version 3 and router ID. IPv6 router EIGRP1, autonomous system 1, and EIGRP router ID 1111. Exit. You have 3 interfaces: gigabit 01, serial 000, and loopback 1. You can use do show IP interface brief. Now, the active interface is gigabit 01, serial 000, and loopback 1. Interface gigabit 01, IPv6, EIGRP1, serial 000, EIGRP1, loopback 1, exit. Very good. Okay, this R2, enter enable IPv6 routing, IPv6 unicast routing, EIGRP version 3 autonomous system and router ID, IPv6 router EIGRP1, EIGRP and router ID 222. Exit. And the appropriate interfaces, 2 interfaces. Okay, do show IP interface brief. Okay, 2 active interfaces, serial 00 and serial 001. IPv6 EIGRP1, serial 001 EIGRP1. Exit. Now R3, IPv4 default route. Okay, go to R3, IP route, the default route to R2 via the exit interface. The exit interface is serial 001. Okay, serial 001 with administrative distance of 200. 200 administrative distance. Enter. IPv6 unicast routing, IPv6 unicast routing, and EIGRP version 3, autonomous system 1, router ID, IPv6, EIGRP1. Okay, sorry, IPv6 router EIGRP1. Okay, and EIGRP router ID 3333. Enter, exit. The interfaces, active interfaces. Do show IP interface brief. Gigabit 01 and serial 0001. Interface gigabit 01 and IPv6, EIGRP1, serial 001. Next. Okay, verify network connectivity. But before to verify network connectivity, do the following. Verify IPv6 and show IPv6 routes. Okay, on R2 and show IPv6 routes. Okay, and R3 and show IPv6 routes. Okay, and for example, on R3, show running config, and IPv6 routing with EIGRP is shut down. Okay, so enable on the router configure terminal IPv6 router EIGRP1 not shut down, exit or end. R2 configure terminal IPv6 router EIGRP1 not shut down, exit or end. R1 configure terminal IPv6 EIGRP1 IPv6 router EIGRP1 not shut down, and okay, very good. And now the neighbor on EIGRP on R2, the two neighbors 3 and 1. On R3, one neighbor number 2, very nice. And for example, on R3, show IPv6 route. Now you can see 1, 2, 3 remote IPv6 routes. 1, 2, and 3. Okay, go to R1, show IPv6 route. 1 and 2. Okay, 1 and 2. Very good. And now on R1, verify the routing for IPv4, show IP routes. Only the default gateway to access to internet. Go to R3, show IP routes. Only the default gateway to internet, and go to R2, show IP routes, and no static routing and no dynamic routing. Okay, so on R2 on internet router, you need two static routes, one to reach the LAN on R1 and another static route to reach the LAN on R3. But another way to do this, another way to permit the connectivity from internet router to R1 and R3 is configured NAT on R1 and NAT on R3. So R2 will not need static routing or any other kind of routing. So configure NAT on R1. Okay, first create an access list. Okay, create an access list and configure terminal. Okay, you are on R1. Be careful and first create an access list number one, and permit the local network. This IPv4 192.168.1.0. This is the network and wildcard. Okay, be careful with the numbers and now configure NAT IP NAT inside source list. The list is the number one, is the source, and destination the exit interface serial 000. Interface serial 000. And use overload for path for port address translation. And set the interfaces for NAT serial 000 is outside. The gigabit interface is inside, and okay, loopback 0 also can be inside for NAT, but I will configure if it's necessary. For now, it's not necessary. Interface serial 000, IP NAT outside, interface gigabit 01 inside. That's it. And similar configuration for R3. Configure terminal access list. I will use number 3, permit 192.168.3.0. The wildcard, okay, use this. IP NAT inside source list 3, interface serial 001, and overload. Okay, this is the exit interface serial 001, enter interface gigabit 01, IP NAT inside serial 001, IP NAT outside, exit. Okay, gigabit 001, gigabit 01 and serial 001. Okay, very good. And now, once all this is configured, verify network connectivity from PCA, ping PCB. From PCA, ping PCB is 192.168.3.10. Ping should not be successful. Okay, so this is okay. Destination host unreachable. Very good. From PCA, PCB with using IPv6. Other. Success. Okay, very good. PCA to R3. Success. Very good. PCB to PCA. PCB to PCA. From PCB to PCA. destination host unreachable. Ping should not be successful. So this is very good. From PCB, PCA using IPv6. Enter. Success. Very nice. From PCB, ping R1. From PCA, ping the simulated web server, the loopback on R1. Okay, go to PCA, be careful, go to PCA and ping the simulated web server, the loopback one on R1. Okay, success, should be successful, very nice. From PCA, ping web server using IPv6. Success, very nice. And from PCB, go to PCB, ping the simulated web server, the loopback on R1. Okay, destination host unreachable. Ping should not be successful. So this is very nice, very good. And from PCB on IPv6, ping the simulated web server. Okay, success. Ping should be successful. Very nice. Now configure GRE tunnel with BGP. Okay, this is the tunnel. The tunnel is configured between router 1 and router 3. Configure GRE tunnel with BGP routing on R1. Okay, on R1, configure the tunnel first. And the tunnel set IPv4 address, tunnel source interface, tunnel destination IP address. Okay, but you need to know the address of the tunnel. Tunnel should have a layer 3 address, and I will add the following: 172.16.1.0.24. Okay, this is the tunnel. Okay, this is the address of the tunnel. Okay, so go to R1 interface tunnel 0. Okay, number is 0. Enter. Tunnel up IPv4 address. IP address 172.16.1.1.255.255.255.0. Okay, I will use the number 1 on for router 1. And number 2 for router 3. Okay, and tunnel source, tunnel destination. Tunnel source is the serial 000. The tunnel destination is the IP address of serial 001 on east. Is on this network is 229. To 165, 200, 229. Okay, you can verify, for example, go to R3 and verify the serial 001 is 209, 165, 200, 229. Is this. Okay, very good. And now configure host route. Set the host route to the tunnel destination with 32 mask using the exit interface. It's only a static route. Okay, exit. Use IP route 209, 165, 200, 229. The subnet mask 32 is this. The serial interface serial 000 is the exit interface. Okay, enter. Now BGP. Router BGP. The local autonomous system 65,010. Enter. The network statement on the GRE tunnel, the network will be the second address on router 3. Should be the number 2, 172.16.1.2. The network. Okay. Network 172.16.1.2. Okay. R1 is 172.16.1.1, but the network will be 172.16.1.2. And the remote autonomous system should be 65,030. 65,030. Enter. Okay, it's network. Okay, be careful. And network statements only for connected networks, loopback 1 and gigabit 1. This is for gigabit 1 on IPv4 and loopback 1. Okay, network 192.168.1.0. Mask 255.255.255.0. The another network for loopback 1 209.165, 201, 0, mask 252. Okay, this for loopback 1. Okay, for loopback 1, the subnet mask is 252. This is the network of loopback 1, the network address of loopback 1, and 252 the mask. This is the host address of loopback 1 and 252 the mask. Enter. Okay, exit, very good. And now on R3, a similar configuration, R3, enter Cisco enable class configure terminal. Tunnel 0, interface, tunnel 0, IP address. Okay, the IPv4 address, the second interface, the second IP on this network, 172.16.1.2, 285, 285, 255, 252. And tunnel source, the source is this, serial 001. The tunnel destination the IP address on serial 000 on R1, the IP address of serial 000 on R1. On R1 and show IP interface brief. Serial 000 on R1 225. Go to R3, tunnel destination 209, 165, 200, 125, 225. Enter. That's it. The route, IP route 209, 165, 200, 225. Theory 2 mask, the exit interface serial 001. Enter. BGP, autonomous system 65,330. Autonomous system 65,030. Router BGP 65,030. The network and only one network. The network is router 1 using the tunnel, that is the first IP. And network 172.16.1.1. And the remote dash autonomous system is 65,010. Remote 65,010. Okay. Router 3 is 172.16.1.2, but the network is 172.16.1.1. Remote autonomous system. Enter. Okay, it's network. Enter. And now you can see the adjacency change. You know, you have a new network is router 1. Configure the network statement. The network statement for this network 30 network 192.168.30 mask 255.255.250. Very nice. Exit. Now verify network connectivity from PCA. Now ping the simulated web server. Go to PCA, ping the simulated web server, enter. Success. Ping should be successful. From PCA, ping PCB. This is the address of PCB. Enter. Success. Thank you for the tunnel. This is success. Ping should be successful. PCB, ping the simulated web server. Go to PCB. Ping the simulated web server. Success. Ping should be successful. Very nice. And from PCB, ping PCA. Okay, enter. Very good. Success. Now implement point-to-point protocol over Ethernet. Configure point-to-point protocol over Ethernet router configuration task for R2. Copy and paste the provided configuration on R2. This. Control C. Open the notepad. Okay. Okay, the username for the client will be case-sensitive customer 1, password, this, create a local pool, from 10.0.0.1 to 10.0.0.10. Interface virtual template 1, a virtual interface with this IP address. The MTU, the peer default IP address pool for DHCP, the authentication chap call in, exit, configure point-to-point protocol over Ethernet global, assign virtual template 1 for this, and on interface gigabit 00 on the router R2 on this interface, gigabit 00 on R2, enable the point-to-point protocol over Ethernet and activate the interface. So copy this to R2. Go to R2, enter password Cisco, enable class, configure terminal, and paste, enter. Okay, and the username, very good. The local pool, very good. Interface virtual template 1 is not accepting the IPv4 address, is not accepting the MTU. The pool is accepted, the authentication is accepted. On point-to-point over Ethernet is assigned at virtual template 1, very nice. Gigabit 00 enable, very good, and not shut down. Okay, so review virtual template 1, interface virtual template 1 dash template 1. Okay, and view the options. IP. Okay, so it's not permitted. Anyway, you can assign this IP address on gigabit 00. Okay, exit interface gigabit 00, IP address 10.0.0 to 54, to 55, to 55, to 55, 0. MTU 1492, exit, very good. Okay, and show running config. The customer, the virtual interface assigned to point-to-point over Ethernet, the virtual interface configuration, the DHCP, encapsulation by default, the authentication. Okay, the gigabit 00 IP address MTU at this configuration. The range of the pool. Now configure R3 as the point-to-point protocol over Ethernet client. Go to R3. Gigabit 00. Okay, this interface on red, gigabit 00. Interface gigabit 00. Enable point-to-point protocol over Ethernet. Point-to-point protocol over Ethernet enable. Okay, virtual access 1 is created and the client uses dial pool number 1. point-to-point protocol over Ethernet dash client dial dash pool dash number 1. Enter 1. Enter. Activate the interface. Shut down. Very good. Exit. Configure dialer interface 1. Create virtual dialer 1. Interface dialer 1. Okay, negotiate IP address. IP address. Negotiate. MTU 1492. 1492. Okay, don't forget the encapsulation. Encapsulation point-to-point protocol. Create dialer pool 1. Dialer pool 1. Point-to-point authentication chap calling. Point-to-point authentication. Okay. Another enter. Dialer pool 1. Point-to-point authentication chap calling. Point-to-point chap hostname customer 1. Point-to-point. Okay, this is the chap authentication, username customer 1, password, this password. Point-to-point chap hostname customer 1. Point-to-point chap password Cisco point-to-point protocol over Ethernet. Exit. Okay, so this configuration is this 1, 2, 3, 4 lines. 1, 2, 3, 4 lines. The next configuration is 1, 2, 3, 4, 5, 5, 6, 5, 6, 7, 8. 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Very nice. And finally, configure a static default route using the dialer 1 as the exit interface. IP route, the default route, and dialer 1 as the exit interface. Okay, and you can verify on R3 and show point-to-point protocol over Ethernet session. Okay, and the session is up. Okay, the session is up. From PCA, ping PCB. From PCA, ping PCB, success. Very good. From PCB, ping PCA. From PCB, ping PCA, success. From R3, ping 10.00.254 is from R3, ping gigabit 00 on router 2. Ping 10.00.254, success. From PCB, ping the simulated web server. This is success, very nice. Oh my god, and configure IP access list. Configure IPv4 extended access list named ICMP underscore access. Okay, go to R1, enter Cisco enable class, configure terminal, IP access dash list extended ICMP underscore access. Be careful with the name ICMP access. Enter. Deny all pings to R1 LAN. Okay. Deny ICMP protocol from any source to any destination. Echo. Okay. ICMP protocol echo. Echo is ping. Any. And enter and permit any other protocols. Permit IP from any to any. Enter. Exit. Place the access list at the correct interface and direction. This is the destination. The LAN of R1, and this is the arrow, the traffic. So apply on this interface outgoing, okay, outgoing traffic. This interface gigabit 01 outgoing traffic. Interface gigabit 01 IP access dash group. The same name ICMP underscore access out. Enter, exit. And ping from PCB to PCA. Ping should not be successful. Ping to go to PCA and try to ping. Okay. From PCB, try to ping PCA. Destination host unreachable. Ping should not be successful. Very good. And from PCA, ping to PCB. And from PCA, ping to PCB. Success. Ping should be successful. Very nice. Now configure IPv6 access list on R3. Go to R3. Configure IPv6 extended access list named limit access. Configure terminal. IPv6 access list. The name is limit underscore access. Okay, be careful. Don't forget the underscore. Limit access. Enter. Deny all pings to the local network. Deny ICMP protocol from any source to any destination. Echo is the ping. Echo request. And permit any other protocols. Permit IPv6 from any source to any destination. Exit. Place the access list at the correct interface and direction. Okay, now this is the another destination. This is the another destination, and this is the traffic. Okay, this is the traffic. And you need to configure on this interface outgoing traffic. On this interface gigabit 01 outgoing traffic. Interface gigabit 01 IPv6 traffic dash filter, the assigned name of the access list, limit underscore access, outgoing traffic, enter exit. And ping from PCB to PCA should not be successful. Okay, and ping from PCB to PCA should be successful. This is incorrect because should be successful. Okay, try from PCB to PCA. Obviously using IPv6. Okay, should be successful. And ping from PCA to PCB should not be successful. Okay, this is incorrect. From PCA to PCB ping should be not ping from PCA to PCB ping should not be successful. Go to PCA, ping to PCB using IPv6, destination host unreachable. Okay, very good. Completion 90%. Okay, you can fix some configurations. For example, gigabit 01 and gigabit 00 description, and you will never know what description your instructor wants, or you will never know what exactly description requires this packet tracer file. And remember the configurations for this packet tracer file, the default gateway and link local addresses for PCs are incorrect. So you will change the mask. You can use 30 for the mask to get more than 90% of the score. Change the subnet mask to 30 for the tunnel, and on R3 should be 172.16.1 to 252, and on R1 is 24. Change this interface tunnel 0 IP address 172.16.1.255.255.252, and so you will get 91%. Okay, thank you very much.